Hey guys, this is AB Unit 5 Notes number 6. We are diving again into integrals, but more on the graphical aspect of it, okay? To give you an idea of how it would work graphically. So here we go. Here's our FLT. Now press play when you're ready. Okay, so this right here has a lot of writing. So I actually made a PDF for you guys. I would encourage you to just print it out. You could probably, at the very least, double-sided if possible, or squeeze 2 pages into 1 page. You might even be able to do 4 into 1 page if you don't mind squinting your eyes a little bit, okay? All right, so you're going to be given a graph, and you have to remember how to really apply the properties of integrals, okay? And in the last lesson, we went over 3 properties with integrals. The one where you have no friends, the one where you could flip your bounds as long as you account for a negative, and the one where you can split your integrals, okay? So feel free to revisit those. But we're hitting this concept called net area, okay? So we kind of touched bases on it. If you guys remember, sometimes your answer when you integrate came out negative or positive. Okay, that implied that you have, if you had a negative answer, that means that your area, the majority of your net area or your total area is below the x-axis, okay? If your area came out positive, that means the majority of your area is above the x-axis. So this kind of illustrates that idea. So here we go. Again, print this out so you don't have to write it out because there's a lot to write if you do. Okay, so here in example A, they give you a few facts, okay? They give you regions A, B, and C in the picture here. And specifically, they tell you that the area of the region is 8, 19, and 11 respectively. So here's what you guys do. You put in your picture. So this is 8, 19, and 11. Now, what they don't tell you is you have to understand what it implies. So notice how 8 is above the x-axis. So you know that that is a positive area, okay? Whereas, I should use a different color, whereas this area, 19, and this area, 11, are both below the x-axis. So that would imply that you had negative area here, okay? So that's something that they don't give you, but you have to imply, right? So here they're asking you, well, what is the value of the integral from negative 8 to 5 of f of x dx? So they're asking you to accumulate starting from negative 8 and then all the way to positive 5, which happens to be the whole picture with given values, right? So all you have to do here is, notice how they don't give you what the function is, so you can't really integrate, right, analytically, but you understand that when you integrate, you're finding the area. So really, this is just positive 8 minus 19 minus 11. And that comes out to, I don't know what that is, negative 11, negative 22? That looks about right. Okay? And it makes sense because the majority of your area is below the x-axis. And it is that easy, okay? The only extra things that you have to consider is knowing when the area is positive or negative, okay? So here we go. Let's try another one. Here's part B. Okay, try this on your own. Press play when you're ready. Okay, so I know that I want to find the area from negative 4 to 4. So I want to make sure that I'm reading my question here. I want to find the area from -4 to 4. So I know a few things. I know that region A is -6 because it's below. Region B is +4 above. Region C is -10. Region D is +7. And region E is -5. But again, I only want to accumulate area from -4 to 4. So really, I'm just adding 3 different values here. So you guys would just write the integral from -4 to 4 of f of x dx is equal to +4 minus 10 plus 7. That comes out to +1. And that implies that you have more area above the x-axis. Not that bad, right? Okay, here we go. Here's something a little bit different. Here's part C. So here, they don't really give you the areas, okay? Like A, B, C, D, E here, right? But you notice that the function is rigid in that it's very linear and that it's turning in corners, right? So they do that on purpose, and you guys will see this a lot on the AP exam. So here's what you do. First, you want to understand what you're looking for. We want to find the integral from 0 to 9. And that means we want to find the area under the curve from 0 to 9. So that's really what they're saying. We want to find the area under this f of x curve from 0 to 9. So if I target from 0 to 9, 0 starts right here, and 9 ends right here. Okay? So if you take a look, it creates geometric shapes. If you notice right here, this right here is an upstanding trapezoid. Okay? And this over here, I'll color it in red, is really just a right triangle. Okay? So if I can find the area of those two, I can just add them up, and then that'll be my net area. Notice how they're both above the x-axis, so I know the areas are going to come out positive, okay? So here we go. The integral from 0 to 9 of f of x dx will equal the area of the trapezoid. Now, the area of the trapezoid, the formula is 1/2 the height. The height will be 5 units high. Since the parallel sides are standing over here, it'll be 5 units high. So that's 1/2 times the height times the length of the two bases. So the length of that top base is just 2 units, and the bottom base is 4 units. So that's 2 plus 4. And that would be the area of the trapezoid. Now the area of the triangle, if you guys remember the triangle, this is 1/2 the length of the base. So from 4 to 9, I'm counting 5 units. And it goes up 4 units. Okay? There, the triangle eventually comes out to 10. And I know it's going to be positive because it's above the x-axis. Okay? Now, the area of the trapezoid is going to come out to, oh gosh, what is this? 6, 30, 15. And I know it's going to come out positive 15 because it's above the x-axis. So my total net area is positive 25. Okay, so here's how you incorporate geometric shapes. All right? Okay, here's part D. Go ahead and try this one here. Press play when you're ready. All right, here we're trying to find the area from -9 to 0. So that's really just from -9 to 0. So right in between those two borders there, give or take. Okay, so here I know that I am dealing with a trapezoid and coincidentally another right triangle. Okay, they'll always give you shapes that you know how to find the area of, okay? So the two areas I know are going to come out positive because they're both above the x-axis, okay? So the area of the trapezoid is just 1/2. The height looks like it's 6. And the sum of the two bases, that's going to be 2 plus, I'm counting 5. Okay? Now the area of that triangle is 1/2 the base, which looks like it's 4. And the height looks like it's 2. Okay? And whatever this comes out to, I'll let you guys figure that one out. All right? Okay. Here's part, what are we on? E. We're going to go through the whole alphabet. Part E. All right. I want you to try this one on your own. It's different, but you have everything you need to solve this problem here, okay? Press play when you are ready or if you need assistance. Okay. First thing you want to do is pay attention to what they're asking for. They want us to find the integral of f of x dx from -6 to 5. So that means we want to find the area from -6 all the way to +5. Okay, so that creates, it looks like two geometric shapes here. It looks like we have the more traditional trapezoid. And then we have a right triangle. Okay. Notice that the trapezoid is below the x-axis, so I know the overall result will come out negative. And I'll just group that, okay? Now the triangle is above the x-axis, so I know it's going to be positive something. All right? So here we go. We'll take care of the triangle first. The triangle is just 1/2. The base is 5. The height is 4. Okay? The trapezoid, remember I already accounted for the negative. Now the height is the distance between the two bases. Okay? I'll put it in pink here so you guys can see. So the height is really this. That's 3 units. Okay? So that's going to be 1/2 times the height of 3 units times the sum of the two bases. So the two bases, it looks like it's 6 and 3. So it's 6 and 3. And you can compute that with your calculator or just by hand. But again, the answer is not what I'm worried about. It's just your setup, okay? On Delta Math, they'll ask you to go all the way through. Okay. So if you really think about it, it's like 3% calculus and 97% just geometry. Okay? All right, here's something a little bit different, part F. Make sure that you're on the right problem here, okay? So here's the last type. So they tell you about regions A, B, C, and D, which are the values that have, the areas that have values indicated in the picture, okay? So then they ask you this. This is how you guys got to handle it, okay? This is where you have to incorporate your properties. So they're asking us for the integral of f of x plus 5 with respect to x from -7 to 1. Okay, so first off, I have multiple terms here, so I'm actually going to split my integral from -7 to 1 of f of x dx, and then plus the integral of 5 dx from -7 to 1. So really, I just split these two terms right here. Sometimes you got to do that. All right? Okay, so we'll take care of the analytical part here. If I were to integrate 5, that would just be, I'm going to let you guys think about that. What's the antiderivative of 5? The antiderivative of 5 is 5x, okay? And then we evaluate it from -7 to 1. right? And I'm going to keep going with this part, okay? Fundamental theorem of calculus states that after we take the integral or the antiderivative, we plug in our upper minus our lower. Okay? All right. So whatever that comes out to, okay? Now this part right here is what we've been working on in the last few examples, okay? So over here in orange, all of this had to be done analytically, aka algebraically, okay? Whereas this, since we don't know what the function is explicitly, we have to solve this graphically. So you guys have to have a really good understanding of what integrals mean from all different directions, okay? So integrating, when you're given the graph, that means that you're finding the area, in this case from -7 all the way to +1. Okay? So they conveniently gave us the area from -7 all the way to 1, which is this area here, and then this area here. Okay? But notice how there's area below the x-axis, so that 12 down here is really a -12, and that 21 up here is really a +21 because it's above the x-axis. So this is really just -12 plus 21. Okay? That comes out to +9, and you guys can keep going here. That's just computations, okay? Okay, so try this one out. Part G. Press play when you're ready. Okay, here we go. The integral of f of x, we're going to split that minus the integral of 5 dx. And we're still going from -6 to 5, -6 to 5. Make sure both integrals have a dx, okay? Okay, so over here, the analytical part, that's just minus. The integral of 5 is 5x from -6 to 5. Notice how I brought down the minus sign here. So that would be minus upper minus lower, whatever that comes out to, okay? That was done analytically. This right here has to be done graphically because we don't know what f of x is explicitly. So we do know that we want to find the area because integrating means area from -6. So from -6 all the way to +5. So sometimes they give you information that you don't necessarily need. Like for instance, this area right here is outside of the bounds, so we really don't need it. So we're just finding the area from -6 to 5, which turns out to be this area in green. So going from left to right, I know that's going to be a -9, a +6, a -3, and a +11. Okay? -9 and -3 because it's below the x-axis. Okay? The area is below. And then the rest is just computation here. Okay? All right. How's it get a little bit different? So here we go. Rapid fire. I'm going to go through these pretty quickly. Part H. We're finding the integral of f of x dx from 8 to -3. Okay? Try this out on your own if you'd like. Okay. So here we're finding the integral of f of x dx from 8 to -3. Something's weird about that. If you notice, the bounds are backwards. Usually the upper bound is the larger value. So if you're going from 8 to -3, you're actually traveling left, which is a little bit awkward. So what we can do is there's a property that allows us to flip the two bounds as long as we account for a negative. I'm sure you guys remember that, okay? And then the rest is the same. So here we're finding some negative value. And then here we're going from -3 to 8. So -3 all the way to 8. So it turns out that it's going to be this, this, and this. Okay, so that's going to be -14 because it's below the x-axis, +10 above, -6 below. This comes out to a negative. And what is that? -4, -10. So that comes out to +10. Okay? Now, it's a little bit weird when you're looking at the picture, because when you look at the picture, it looks like there's more area below the x-axis, and there is. But because they were originally asking to go left, your area turns negative as well because you're going backwards. So that's why it's a little bit weird to interpret what +10 really means. Okay? So going from -3 to 8, there was more negative area. Let me write this down. But because we went backwards, it's like a double negative. It turns into a positive, okay? But anyways, let's keep going. Part I. We're going to go through the whole alphabet. Here we go. Try this out here. Press play when you're ready. Okay, we're finding the integral of f of x dx from 6 to -2. So that looks a little bit backwards, so we can flip that to -2 to 6 of f of x dx, as long as we account for a negative. Okay, so we're really finding the area from -2 to 6. Okay, so that's really negative. Notice how I bring everything down first, and now I'm looking inside from -2 to 6. That 6 looks like it's negative in area. That 7 is above, so positive, and that 12 is below, negative, and whatever that comes out to, okay? Hopefully you guys are seeing the patterns here, right? How do things get a little bit different? Here's part J. All right. So here, you'll notice that there's an absolute value around the function. Think about what an absolute value does, right? An absolute value pretty much turns everything positive. Okay? So what that means is anything that appears negative will turn positive. So anything that's below the x-axis, for instance, that right there will be reflected into something positive, if I'm drawing this correctly, right there. Okay? And this down here will be reflected up here. That's really what's happening graphically. So if I were to trace the absolute value of x, just to show you what it looks like, the absolute value of x would look like this, where there's really nothing below the x-axis. So that highlight in green is really the absolute value of x. Okay? So here we go. We're finding the area from -8 all the way to +7. Okay, so that's going to be +6, +10, +18, +16. So if you notice, there's not a lot of work to be shown. It's just a lot of analysis here. Okay, whatever that comes out to. All right. Part K. Try this one here. Press play when you're ready. Okay, here's another case where it's a little bit backwards, right? We can easily reverse the bounds so that we're going in order from left to right. But as always, if we flip the bounds, we do have to account for that negative. Okay, so we're going from -7 all the way to 0. Easy peasy. That 9 would be positive. That 11 would be negative. And whatever that comes out to. Okay. All right. Part L. How many more do I have? I have 2 more. Okay. Part L. Okay. What's weird about this one? So you might notice that there's a little coefficient of a 4 right there. Okay. But if you remember the properties of integration, coefficients can just pop outside of the integral. So that's really the same thing as 4 times the integral of f of x dx from -4 to 8. Okay, constant multiples can always go outside of the integral. It's kind of like with derivatives, how you ignore the coefficient and then you bring it back later. So this is really 4 times, and I'll leave space. I'm trying to find the integral from -4 to 8, so I'm trying to find the area from -4 to +8. And I'm only going to focus on those values in between. So that looks like, I'll try to squeeze all of this in here. We have a -7, +9, -5, +8, -4. And whatever that comes out to. All right, hopefully you guys are seeing the pattern. Last one, part M. Okay, so they give you some facts. This one is a very popular one on the AP exam. They tell you that the integral from -2 to 0 is -3. The integral from why is there a -0 there? Is 13. They meant 0, not -0. And then they ask you this question here. What is the integral from -2 to 3? So here's what we do. The integral of f of x dx from -2 to 3, we could actually use that third property to integrals, okay? And I would go ahead and go from -2, but I would stop at 0, and then I would continue at 0 and go all the way to 3. And I do that specifically because I know a little bit about these integrals specifically, okay? So here, if you notice, I'll draw some arrows. The integral of f from 0 to 3 is actually 13, so I'm actually going to put 13 right there. Now, this one's a little bit weird. The integral from -2 to 0, well, actually, no, it's not. It's the same thing. That right there is -3. Okay. There you go, +10. Boom. So you would have to split that integral. You know, going from A to C is the same thing as going from A to B, then B to C. Okay, I guess this one's a little bit easier than I expected. Okay. Nevertheless, that's pretty much it. You guys are just analyzing a lot, okay? If you have any questions, reach out to me.